All right, Harmony Science Academy Algebra 2. We're going to look at transformations, but before that, because of yesterday's start to the second semester, I was a bit concerned. So let's just talk about attributes real quick, specifically domain and range. Okay? Should be one of the easiest things you do, even though it's really not easy, right? You really have to have some math background, but you guys have math background, okay? So sometimes you forget. So let's go and talk about domain here real quick. Okay. Now I have these pencils here because I've asked you guys in the past to apply the test, the pencil test. When you do these, it makes your life easier. Okay. I know it seems um, maybe a little elementary, but when you stop using it, you start making mistakes. Okay. So anyway, so for example, domain is left and right. So this red dot tells you to put your pencil at the origin. Okay. You're gonna go left and stop when we run out of graph. Okay, we didn't. So in that case, we have what? Negative infinity. Okay, we're just talking left to right. Okay, with a parenthesis. Now I'm gonna go ahead and go back. Now I wanna go to the right and stop when I run out of graph. I don't, so that's infinity. Okay. All right, really that simple. So now let's go ahead and do the same thing, but with range. Okay, you get your pencil and you put it on the origin. Range is down and up, real simple. So grab your pencil and stop when you run out of graph. We don't. Negative infinity. Stop. We don't. Positive infinity. Okay. So really, it's that simple. Now let's try another one just to prove to you guys that it really is that simple. Okay. All right. Let's pick. All of these look like fun, but I guess this one right here. Okay. Let's do his domain. So you start here. I gotta go left, but there's no graph there. So then that means 0 is going to be the farthest left I go. Now I start going to the right. I don't run out of graph, so that's going to be infinity. Okay? All right. Now we're going to go range. Okay? I want to go down, but there's no graph there, so that's it. Okay? I want to go up, and there is graph, 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 graph. And guess what? Little by little, it keeps increasing, so we have infinity. Okay? So, although I could spend more time on this, we've done it before. Apply the pencil to your domains and range, okay? All right. We'll give you guys time to put that in your notes. And here we are looking back at transformations from before, okay? We've been here before, okay? If it's a negative up here, this kind of reflection. If it's a negative in here, you've got reflection on the y-axis. All right, and all these good stuff. Remember this here, it says, this is the sign, so ignore the sign. If the number by itself is bigger than 1, vertical stretch. If the number itself is less than 1, vertical compression. This one's always easy. This one gets tough because it's kind of in reverse, okay? So play with your calculators, but basically ignoring the sign, if the bigger the number is than 1, you start getting this compression. And once you have this smaller than 1, like some kind of fraction, simple fraction, you get a horizontal stretch. Okay? So this one you definitely want to go slow and look at it. And these are easy, right? After the minus, whatever number's here is your horizontal shift. And out here, you get your vertical shift. Okay? Now that's what we've been doing pretty much the whole year. This time it's going to change a little bit. Okay? Just a little bit. So I'll give you guys time, pause here to take notes. But you still have what? The sign doing the reflection x-axis. The A still having the same effect. Okay? The B's and this part's in different locations, but they do the same thing. Okay? The bigger the B, the more of a horizontal compression. Once you get a simple fraction, okay, smaller than 1, you start getting a horizontal stretch. Okay? And okay, this negative in here in front of the x would give you a reflection on the y-axis. C, even though it's in a weird location, okay, or different than what we're used to, it's still gonna give you after the minus the horizontal shift, and out here the vertical shift. Okay, so overall the same stuff, it's just set up a bit different for exponential functions. Okay, all right, so we're gonna go ahead and do a problem like that, and in a little bit you guys will get to practice these. Okay, and yes, you're encouraged to copy this every time because it's gonna stay in your head. Okay, so it's not about doing a lot, do few, but do them with all these details. Okay, but anyways, before we go there, let me go and try and do a quick little recap on the calculator. Okay, pay attention. Just this is something you guys could and should do on your calculators. So I'm starting off with 2 uh, exponent x. Okay, now everything I do is going to be some kind of transformation to this guy, so pay attention. We're going to go through it pretty fast. Okay, if I've got the negative, okay, you guys should look at your notes. We get a reflection on the x-axis. Okay, now in front here I'm multiplying by 3, okay, which is a number bigger than 1. So I get a vertical stretch. Okay, imagine this graph is a string and it pulls it up. Okay, so it stretched it. Now a is less than 1. Forget the sign. Okay, so what's that going to do? It's going to be a vertical compression. It pushed the string down. All right, let's go to now notice what happened here. B got even bigger. Okay, so what that's going to do, it looks like a vertical stretch, but because we're dealing with B, this is a horizontal compression. Okay, now I've got myself a number less than B. Okay, and I probably should have even gone lower. We'll keep it here the way it is for now, but what you're going to expect is the opposite. Okay, so now we have a horizontal stretch. Okay, so let's go ahead and keep going. Now we have the negative in front of the x exponent, and we would expect it to do what according to your notes? A reflection off of the y-axis. Okay, the next one is a minus c, right? So this is not negative 5. After the minus is the c. C is 5, so it's going to go 5 units. Okay, to the right. It shifted 5 to the right. Okay, in this case, I have a plus 5. It's not a positive 5 because I need a minus, right? So it's minus negative 5. So it's going to go 5 to the left. Okay, we've been here before. Now we've got, of course, the plus 5. That one's super easy, right? It's going to go up 5. And did I do one more? No, that's it. Okay. So again, if you can go through that on your calculator, it's going to pay off. So let's see here. Let's go ahead and do one, and then we'll get you guys started working with your partners in class. Okay. So sketch the graph. Okay, you've got calculators, so that's not going to be the difficult part. The main thing is the transformations. So once you have this, you set up this template and you fill it in. Okay. All right. So do we have a reflection on the x-axis? It's a yes because of the negative. Okay. Next, do we have a vertical compression? Okay. It is less. So in this case, it's going to be a yes because of the half. Which means, do we have a vertical stretch? That's going to be a no. All right. Next, let's slide over to B. Okay, again, B's always kind of got some considerations, and just like you saw earlier, these are very generic notes, so you do have to kind of investigate this a little further on your calculators. Okay, in general, the bigger the B, the bigger the horizontal compression, the smaller the B, okay, absolute value, the the uh, the impact on the horizontal stretch. Okay, all right, so um, we're looking at B. Okay, it's a 2. This is the parent function we're dealing with. Okay, pay attention to that part. If they compared this to another function with a 3 or 4, then you would compare it. But in this case, it's just standard. So pay attention to that part. It's a no, no. Okay, because we're dealing with, let's call it the parent function, which is like I had in the calculator, 2 to the x. So the fact that it stayed the same means that there is no horizontal compression or horizontal stretch. This is different with these types of um, functions, okay, these exponential functions, okay? So we'll probably have that conversation in class again, but once again, only if you will you declare a horizontal compression or stretch if you're comparing with another parent. So for example, let's call this one h of x. Okay, if you're comparing it to him, then you would say, okay, there. What is the difference? This one has a horizontal compression. Okay, since it's bigger. If you had, let's say, something like, which we saw in the calculator, um, 1.5, because it's smaller than the 2, you're expecting a horizontal stretch. Okay. Again, don't tap out now. B's the only one that we're gonna have a continued conversation on. Okay, the rest of them are as easy as they've always been. All right, so let's continue. Reflection on y-axis. I'm looking for a negative here. I don't have it, so it's a no. I do have x plus 2, which should be x minus negative 2. Be careful. So it's going to be a yes here because of what? Not a 2, a negative 2c, okay? And then D. D is not a 2. It should come after a plus, so this should be, let me do it here. This one should be, or I guess, like we've done before, we should write in standard form. So let me squeeze it in here real quick. F of x equals negative half x 2 x, I can put this in parentheses, minus negative 2 plus negative 2. Okay. So I'm not putting in steps because we've been here way too many times and you guys should already have this skill set, but it's worth reminding you guys to use your skill set. Okay. So there's the yes, negative 2. In this case, we have plus negative 2 here, so it's a yes, negative 2. Okay. That's it. That's our intro, and now we got to start practicing in class, so I'll see you then.